Hi, good morning. This is Alvin. I do not know when was the last time I take a video and uploaded it to the YouTube. So it has been a while. So hope everything is fine with you. And I'm doing some tests of the Gaia DDC and the Terminator Plus. And I have here not a typical desktop setup. I would say it's a pretty high-end desktop headphone setup with the Gaia DDC, a computer, a Terminator Plus as a DAC, and a headphone amp from DENAFRIPS, the Artemis. And the headphone that I'm using is the HD 600. So let's go through the connection. So I have here is it's a pretty normal laptop from Lenovo. USB output to the Gaia DDC, USB input. So the laptop is acting as a transport to send the music signal to the Gaia DDC. The DDC is the digital to digital converter, so it converts the USB signal to various output here. Let us look at the back. Let's zoom in at the back. So the Gaia DDC has various input: the USB input, the AES EBU input, the optical input, and the coaxial input. We have two special connection here. It is a clock synchronization input where you can connect it to the Terminator Plus clock output. I'll come to that later. So there are a couple of outputs here: the coaxial output, optical output, I²S output in the form of HDMI and RJ45. When I say in the form of HDMI and RJ45, it doesn't mean that this HDMI is compatible with the rest of the HDMI commonly found in a TV or in a Blu-ray player. So it is not compatible with the HDMI that is in the Blu-ray player, and the RJ45 is not the Ethernet kind of RJ45. I²S has no industrial standard, so most of the manufacturers use HDMI connector and RJ45 connector. And we have here the AES EBU output. So the connection goes like this: USB input from the laptop, or you can have the other input from the rest of the sources, and the digital output goes to the external DAC. What I have here is from DENAFRIPS, the Terminator Plus. The I²S output from the Gaia DDC goes to the I²S input of the Terminator Plus, and the output of the DAC XLR connected to the headphone end using the XLR cable. And this is the headphone end. And so we need to address this clock synchronization. The Terminator Plus uses oven control crystal oscillator. It is in the DAC itself. It is closer to the digital conversion circuit, and it is best to put the good clock in the DAC. But of course, the Gaia DDC, being the flagship DDC of DENAFRIPS, also uses the same OCXO, oven control crystal oscillator. But the reason why we have the clock synchronization from the DAC to the DDC is both of the DDC and the DAC clock can be synchronized. It gives you timing accuracy, more details, and cohesive flow of the music. I mean, you have to try it out to hear the difference. So I have this connected, and we'll go to the front and let me show you some of the operation of the DAC. Just so you know, the remote control here has no function. None of these devices has a remote control function. I put it in here just for aesthetic purpose. Okay, so the Gaia DDC is connected to the laptop. So it's a Windows laptop. You will have the driver installed, and the USB DAC will be detected in the Windows PC as a USB high resolution audio device. And if you go to the about the information page, you will see the manufacturer is DENAFRIPS and the name of the USB input, and of course you have the PID and VID. It is a device ID, so you don't have to bother about this. So this is the driver for Windows. For Mac and Linux, there's no driver required, but the you have something similar where you can see USB high-res audio detected when you connect this USB DDC or DAC to the computer. So I'm using a HQ player to simulate playing high resolution file, or rather, in fact, most of my music are 44.1 kHz, but most of the customer would like to have the ability to upsample to, let me see, PCM 768 and DSD 512. So I recently get myself familiarized with the HQ player so that I can demonstrate this and do some troubleshooting, or rather do some tests of the DDC and the Terminator Plus with all this high resolution music. Let me show you the front panel of the Gaia DDC. It's pretty straightforward. You can choose the input that you would like to use. So at the back you see you have USB input, coaxial input, AES EBU input, optical input. So currently I'm using USB input and the USB light is light up. We have here the clock signal. If the clock LED is on, it means that the Gaia DDC bypassed the internal crystal oscillator. It bypassed the internal OCXO and is expecting to have the external clock connected to the back of this panel, the two cable that are connected to the Terminator Plus. And because the Terminator Plus has the clock output function, where you can output the OCXO clock to the DDC, so it's a good idea to have this feature enabled so that you can have different tastes of whether you want to have clock synchronized, or you prefer the other one without the clock synchronized. So the clock synchronization can be turned on and off by using this setup button. Press the setup button and toggle this optical button. You notice the clock LED on and off. LED on means the Gaia DDC is expecting the external clock. Clock LED off means it is using the internal clock. So what I would like to show here is the clock synchronization, and my source is USB input. And same apply to the Terminator Plus. The clock can be enabled or disabled by doing some combination of front panel button. Press the mute button and press the input minus button, where you can change different clock output frequency from 44.1 to 25 MHz or 45 MHz. To synchronize the two devices together, leave the LED button here to optical 1 and wait for a while. The DAC will be back to normal operation mode. How to tell this is happening? The optical LED should be off and it will go back to the previous input selection after a while. So let's have a silent moment to wait for the DAC to back to normal operation. I do not know how long, so I hope it is a short while. Okay, we are still waiting. Okay, now it back to the I²S A input selection, where this is the input that I was selected just now. So I²S from the Gaia DDC and USB selected, and currently the last play was DSD 512. 8 times means 8 times 64 is 512. You will notice the 44.1 LED is also light up. It is because the DSD 512 is 44.1 kHz base. So the 44.1 K LED light up. Let me play some music using the HQ player. Okay, let's see the PCM 768. PCM 768, and let me play it. Oh, sorry, I gotta close this window. I gotta close this window and play PCM 768. PCM 768. Oh, sorry, it's not playing. I'm still playing the DSD. Let me change the setting to. Hang on a second. Okay, I need to familiarize myself with the HQ player. PCM. Press OK and start playing a track. And we have here USB selected, clock signal, and PCM 768 is streaming from the Gaia DDC to the Terminator Plus. So the Terminator Plus I²S input and PCM 48 kHz base and 8 times. 8 times 48 is 768. So they are playing the DDC and the Terminator Plus is playing PCM 768. Let me see, you can hear it. Alright, let me switch to DSD 512. DSD 512. Sorry, the video isn't very nice. I know I'm not a very good director, I think. Okay, DSD 512. Here we go. DSD is playing, so the DSD LED light is on. 512 LED is on. It can be confusing here. 352.8K and 512, and explained previously, because the DSD is in 44.1 kHz base, so the LED light out here and the LED light out here is actually meaning it is playing DSD 512, and the Terminator Plus should be receiving the same DSD. 8 times 64 is DSD 512 using the I²S interface. And let's hear the music from my faithful Sennheiser headphone. Alright, the music is playing, so you can have fun of DDC and the Terminator Plus using pretty high resolution. I recently found that when using headphone, upsampling gives a little bit more sensational musicality. But when I was using loudspeaker system in my setup, I actually prefer not to upsample using the HQ player. So your journey may vary, and do try it out at your own setup. So this is how my setup, my test be like today. Oh, I forget one very important thing. Because we are using the I²S input, the pin configuration has to be set correctly. Gaia DDC from DENAFRIPS, Terminator Plus DSC from DENAFRIPS. The configuration of the I²S input A is 000. So press the mute button and press the face button multiple times. You will see the LED of 1x, 2x, 4x light up in a binary form fashion. As you also notice, in some of the mode, it produces noise. The noise is because the HDMI I²S signal is not locked correctly. So you will have this noise if you didn't configure correctly. So my advice is to turn down the volume to a very safe volume, because you don't want to blast your loudspeaker or your headphone while you are doing this I²S configuration. So turn down the volume. Play some familiar music. The best test tone to use is those left-right channel tests and in-phase or out-of-phase channel testing. So also all these audio tone tests allow you to be sure that the I²S configuration is the correct one with the left-right channel in place, and also the in-phase and out-of-phase tone is correct. So I have this Tidal audio tone test utility. It's an album from Tidal that I use to configure the I²S very frequently in my system. So back to the I²S configuration. I²S A is selected. Press the mute button and press the face button multiple times. And let me see. So the configuration is 000. It gives this is the correct configuration for left and right channel, and in phase and out of phase play correctly. So once you have configured this with low volume, and you can turn up the volume to hear the music playing correctly. Okay, that's about it, and thank you for watching.